Student, in this video, I am going to derive the expression for electric field due to an infinite plane sheet of charge, which is also the application of the Gauss theorem. It means here the charge is distributed on a thin sheet, uniformly distributed, and our aim is to find electric field due to this plane sheet of charge at distance r from it. Suppose this one is a sheet of charge, and here charge is given to the sheet here, which will be distributed throughout its surface, and our aim is to find the electric field due to the sheet of charge at distance r from it. For this purpose, let us consider P be a point at distance r from the sheet of charge where electric field is required or where electric field is to be calculated. To symmetrical to the point P, we'll take, or we can also consider the point P on other side of the sheet, and suppose that point is P dash at the distance r from it here. Dear student, you know, for finding the electric field at distance r from it, means at point P, first we will draw a Gaussian surface. So first we will draw a Gaussian cylinder cutting to this sheet and passes through the point P and P dash. Remember this distance from here is also how much here? R. So let us consider a thin sheet of charge having surface charge density is sigma, and all of you know surface charge density sigma is equal to Q by A, charge per unit area. And let P be a point at distance r from the sheet where the electric field is required, and this point P is lying at distance r. To symmetrical to this point P, you can also take another point P dash on the other side of the sheet, and now we'll draw a Gaussian surface or Gaussian cylinder cutting to the sheet and passes to the point P and P dash. Now you see here, in this case, positive charge is given to this sheet here, so electric line of forces will be always goes outward. And now this one is the right plane end, this one is a plane end, this one is also plane end, and this one is what here? Chord surface of this cylinder. This one is called left plane end, right plane end, and this one is a chord surface, and our aim is to find what is the total electric flux passes through this Gaussian cylinder. So for finding the electric flux through this plane end, as you know, first we will consider a small area element on this plane end, and suppose that area vector is dA and electric field at this point is E. And as you know, the electric flux through the small area element is how much here? Vector E dot vector dA. And for finding the electric flux through the entire plane surface, we will integrate it. So this will give what here? Electric flux passes through this entire plane surface, which is passes to the point P. Similarly, we can find the electric flux passes through the entire plane surface at P dash, and the electric flux passes through this chord surface area. So for finding the total electric flux, first you will find the electric flux passes through this P dash and plus this chord surface, and we will add it. So the electric flux through the whole Gaussian cylinder, dear student, once again I would like to clear it here. At this point P, area vector and electric field both are parallel. Here also the area vector dA and electric field both are parallel, but on the chord surface electric field and area vector both are perpendicular. So electric flux through the whole Gaussian cylinder, phi E, this should be equal to total electric flux passes through E dot dA. Here plane or through P, means this one is a plane end which is at P, plus total electric flux vector E dot vector dA at P dash. Actually, here P or P dash means I am taking the surface, plane surface either at P and P dash, plus here whole electric flux passes through the curved surface. This one is curved surface. And phi E, this equal to whole integration E dot dA for this P, you can write here E dA cos 0, plus for this P dash also you can write here E dA cos 0, and plus for this one you can write E dA cos 90 here. And as you know, cos 90 is equal to 0. So phi E is equal to, you can write here, whole integration, take E outside here dA, because cos 0 is equal to 1, plus E, this one is dA plus 0. As you know, cos 90 is equal to 0, so this term becomes 0. So total electric flux becomes phi E is equal to E and whole integration for this closed surface dA, it means total area of this plane surface, and let the area of this plane surface is how much here? A. So you can write this one is E into A, plus this one is also comes E into A. It means this phi E is equal to 2EA. Suppose this equation number 1. This one is by your calculation total electric flux passes through this entire Gaussian cylinder. But by Gauss theorem, you can write phi E is equal to Q upon epsilon naught, and both electric flux should be same. So from equation 1 and 2, you can write here 2EA is equal to Q upon epsilon naught, or E is equal to Q upon 2 epsilon naught A. And here at place of Q by A is what? Charge per unit area, and at place of Q by A you can write its surface charge density, which is sigma. So you can write here E is equal to sigma upon 2 epsilon naught, where sigma is equal to Q upon A. So dear student, the electric field due to infinite plane sheet of charge at distance r from it is equal to sigma upon 2 epsilon naught. And this result is very interesting. Why? Because it is free from r. There is no term of r. It means electric field due to infinite plane sheet of charge at any point near it, either closer to this one or at the different points, electric field will be remain same. It means if you will take the point near the sheet of charge at the different positions, then electric field will be remain same. It means it does not depends on the position of the point P. And when you will draw a graph between the electric field and distance due to this plane sheet of charge, suppose this one is electric field and this one is R, then in this case, you know, electric field due to sheet of charge, plane sheet of charge, does not depends on the position of R. As you know, it is free from R. It means electric field near it at any distance is remain constant. This will be shows the constant value of the electric field. So dear student, always remember this: electric field due to an infinite plane sheet of charge, or you can say sheet of charge, is equal to sigma upon 2 epsilon naught, and it is independent on the position of the P. Thank you.